Hey guys, welcome back to Learning from Gliders. If you haven't already, take a look at part 1 of this 3-part video lecture first, because I'll be bringing up concepts and terms from the first video. So make sure you have watched that before moving on to the second one. Okay. So on part 2 of Learning from Gliders, we're going to be learning about the center of mass versus the center of lift. You may have heard of these terms before, but if you haven't, we're going to be reviewing them from the beginning, so don't worry. And we're also going to be learning about how our glider's flight is impacted by these two values. So let's start with the center of mass. Center of mass, also called the center of gravity, is a single point of an object where weight is even on all sides. So weight is even on all sides. What does this mean? Let's simplify the problem a little bit. Think of a 12-inch ruler. There is a point on this 12-inch ruler where the effect of gravity is equal on all sides. So if you're thinking where I'm thinking, or where the name implies, it's right in the center. So because it's a 12-inch ruler, right at the 6-inch mark, right in the middle, you can place your fingertip right under it and you'll see that the ruler balances. So what does this mean? It means that the weight on the left side of the ruler is equal to the weight on the right side of the ruler. So there is a perfect balance. So that was a ruler. Let's think about a three-dimensional shape. You see in the picture there is a block of cheese. I have something similar, except this is a block of wood. It's not a block of cheddar cheese. But in the same way, if you have a block that has a width of 6 inches by 6 inches and a height of 2 inches, the center of mass is actually not on the surface, but it is directly inside of the block itself. And where would that be? It would be 3 inches up the length, 3 inches in up the width, and then 1 inch deep into the wood. So right inside the center of this block is its center of mass. So for our lesson and for our purposes, let's try to find the approximate center of mass of our glider. Okay, so just a forewarning, this is a good enough guess. We're going to make a few approximations. The first approximation we're going to make is that we're going to assume that the glider is perfectly balanced to the left and to the right. The other approximation we're going to do is we're going to take the wing out of the equation. The reason I'm taking the wing out of the equation is because for our experiments on this video, we're going to be moving the wing back and forth. So we actually don't want to account for that when we're accounting for the center of mass. So what you have left is a fuselage and then the two tail components. So how do you find the center of mass? Well, just like the ruler, you try to find the point on the fuselage where if you place your fingertip right underneath it, it'll balance. See? And again, to review, what does this mean? That means gravity's effect on the left side is the same as the gravity's effect on the right side, and there's a perfect balance. I've gone ahead and indicated with like a little pen mark, see, right where my center of gravity is. You can feel free to do that yourself. So pause the video right now, carefully take off the wing, and try to find the center of mass of the glider. You're actually going to find that it is kind of near the back of where the cockpit is. Okay? Oh, and especially when you are taking the wing in and out of the slot along with moving it, make sure to be careful. Balsa wood is quite fragile, especially the wing. Okay. So once you have finished with that, we're going to move to the center of lift. The reason these two centers are related is because what we learned from the last video is that gravity and lift are two opposing forces for the most part. And just like the center of gravity, the center of lift is essentially the same thing. It is the point on our aircraft where the lift is equal on both sides. So remember, our lift comes from our wing. And there is a point on this wing where there is such thing as a center of lift, or the aerodynamic center. And it's not the same as the center of gravity. And a good rule of thumb for where the aerodynamic center of the wing is the quarter chord length point. Let me say that again. The quarter chord length point. So what is that? So if you have the wing, you can see it better in the picture in the slides. A chord of the wing is the length this way. So length along the fuselage. And for our wing, it has a chord length of 2 inches. So a quarter of that would be 0.5 or half an inch. And so just about here. See, just about there where my fingertip is. And that is the aerodynamic center approximated of our wing and aircraft. Okay. So you might be saying here, 1 second, Daewon, I paid attention in our last video, and I know that other than the wing itself, there's one more place where lift is coming from for our aircraft. You're right, it's the horizontal stabilizer. It also creates lift. However, for the simplicity of our experiment, we're going to ignore that and just generalize that all of our lift comes from the aerodynamic center of our wing. For the most part, this is true because most of the lift comes from the wing. So it's safe to make that generalization. Okay, so for the rest of the video, we're going to be trying 3 different scenarios. We're going to be trying to fly our gliders with the center of lift before the center of mass, with the center of lift after the center of mass, and then the center of lift and the center of mass at about the same point. We're going to find out what happens and why it happens. Okay, so the first case, center of lift before the center of mass. So if you see on your glider, there is a slot for the wing to go through. And it is actually enough room that you can place your wing right under the cockpit. See, you can slide it all the way forward. And so if you have marked on your gliders, remember the center of mass is at the back of the cockpit, where now the center of lift is near the front of the cockpit. So what do you think is going to happen when you fly this? Why don't you pause the video right now and try it? Okay, are you back? So what happened? Did the airplane tip up or tip down? That's right, it tipped up. And why is that? Well, as our airplane is flying, or once it leaves our hand, the center of mass or gravity is going to be pulling it down from here. However, as this is being pulled down at this point, lift is being generated from this point. And so this way it's shooting up, and from here it's shooting down. And so there is a rotation, or what is called torque, a rotational force that is happening on the aircraft. And so the glider is going to be gliding and then sliding up, 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 and then it hits this point called stall. And stall is when the glider, or I guess the wing in general, has angled up to a point where it can no longer generate lift. And so you'll actually see that it goes up and then boom, it just drops straight down because all lift has been cut from the aircraft. If you weren't able to see that, make sure to just try it again. Make sure there's no wind around you. So try to do it in an indoor area versus an outdoor area. Okay, so we're going to be trying the opposite. The center of lift after the center of mass. So our wing doesn't slide back actually that far, but there's one trick you can do. So you can get a quarter and rubber band it to the front or the nose of the glider. Like so. Let me show you after. You can rubber band it, you can tape it as well, but essentially it's near the front. Then you will see that if you were to take the wing out, try finding the new center of mass of the glider. You'll notice, for me, it's about here. Yeah, quite near the front, right? Very close to the nose. So what does this mean? Because of the newly added weight to the nose of the glider, the weight and the effective gravity on this side is equal to the effective gravity on this side. Okay. So I'm going to carefully slide my wing back in here. Great. Okay. And I'm going to put it all the way towards the back. So once again, our center of mass is towards the front, where the center of lift is towards the back of the cockpit. Now what's going to happen? Try this experiment right now for yourself. Feel free to pause the video. Okay, now that you're back, did you see what you expected? It's the exact opposite of what happened when the center of lift was before the center of mass. It tilted downward. In fact, it did a complete nosedive right towards the ground as you try to glide it. And that's expected. Why? Because your aircraft is being pulled down by gravity towards the front, so it's already tipping downward. And as it's tipping downward, the center of lift here, which is toward the back of the aircraft, is trying to push it up. So it's even accented forward. So it's like this, and then nosedives right down. And then the third experiment is how most likely you should be flying the glider. The wing all the way in the back of the slot so that the center of mass and the center of lift is right on top of each other. This would cause it where there is a balance of force. There's lift going up and gravity going down. And there is no torque on the glider. So feel free to pause the video here and try it out for yourself. And you'll see that it performs quite better than the other two scenarios. Okay. So when you're designing an aircraft, what should you do? Should you put your center of lift before or after? Or obviously, just like a glider, should you put it at? Well, it depends, right? So for commercial aircrafts, actually, generally you want to put the center of lift to be behind the center of mass. So you want the center of mass to be forward, whereas the center of lift is obviously on top, like top of the wing here. Why is that? Well, you're gonna have to visualize a bit with me. There's such a thing called the angle of attack when it comes to aircrafts. What is angle of attack? Angle of attack is how angled the aircraft is as it is flying. So when it is flying perfectly straight, it has a 0 angle of attack. But then if it tips upward, it has a higher angle of attack. Versus it tips down, it now has a negative angle of attack. Okay? So it's higher angle of attack. And in general, for most wings, as you increase the angle of attack, the lift increases up to a certain point. And then at a certain point, it just completely stalls, and then it goes to no lift. But for the most part, higher the angle of attack, the more lift is generated. So what happens is there's a center of lift that's here, and then as the aircraft starts to tip upward, up, the weight is the same, so the center of mass is here, but then the lift, which is towards the back, increases. And so it actually balances out. In the same way, if it happens downward, it balances back out. See? This is what creates a stable aircraft. And you want this for commercial passenger aircrafts because for most passengers, flying level straight is what you want and what feels the best and what is most comfortable. However, certain types of aircrafts, such as fighter jets, like the F-22 Raptor that's pictured below, you actually want unstable aircrafts. You want aircrafts that are able to have quick maneuvers, able to turn during high speeds, and when in dogfight situations, be able to outmaneuver different aircrafts. And so you actually don't want stability. So you put the center of gravity towards the back. And that's actually why the F-22, or one of the reasons why it has engines towards the back. For most aircrafts, engines are super heavy. And so if you have the engine towards the back of the airplane, you move the center of gravity towards the back. Whereas, remember, for a passenger aircraft, you want the center of gravity towards the middle. So that's why you have the engines towards the middle of the aircraft. And you're actually going to see this if you are ever fortunate enough to fly when the plane is not at full capacity and there actually aren't that many passengers. Your captain, at least until you go airborne, they're going to want you to be sitting towards the front, not towards the back, because they don't want to move the center of mass too far back so that it is at the same point or worse behind the center of lift. So that concludes our second video. Again, I hope you were able to learn stuff, and the challenge questions helped you to think a little bit more about how you could learn more about this. And so I'll see you in the third video where we're going to be talking about the glide slope. And it's actually going to be a bit of a shorter video where we do labs on your own. All right, see ya.